Hello guys, in today's class we shall discuss effect of harmonics on three-phase induction motors, which includes cogging and crawling. Okay, so before getting into this, that is cogging and crawling, let us understand first what harmonics are. Okay, so before going into that, let me divide the harmonics into two parts. One is your time harmonics, other one is space harmonics. So harmonics can be divided into two parts or classified into two parts. One is time harmonics as well as space harmonics. And here we are not discussing time harmonics, we are discussing only space harmonics. The reason why we are doing that means is time harmonics is not predominant here, it is not effective, okay, which will cause harmonics very less, you can say, in other words. So that's why the reason we are not considering time harmonics, we are only considering the space harmonics. Okay, and we know that in the earlier class and all we have studied, we got some torque slip characteristics or torque speed characteristics of induction motor, maybe three phase or single phase induction motor. It was somewhat like this. Yes, here you can see there are a few waveforms of different rotor resistance and all. Don't worry about the different shapes and all, but pattern is all same. Okay, means they are what I'm trying to say here is they are smooth here. Okay, they are here smooth. So only we're going to get torque slip characteristics or torque speed characteristics smooth only when you have air flux or air gap flux if it is sinusoidal. If air gap flux is sinusoidal, then only you get what? Torque and slip characteristics smooth, and the performance of the induction motor will be good. Okay, the performance will be better in terms of power factor, everything, efficiency. But actually what happens, we know that there are present of slots in both stator as well as rotor. So what happens, this causes uneven distribution of the flux, air gap flux in between stator as well as rotor. Okay, since the rotor and stator are not smooth, so what happens, the air gap flux will be also not smooth. So actually it should be sinusoidal, the flux should be actually sinusoidal, but here what happens, due to the unevenness in the stator slots as well as the rotor slots, so what happens, the air gap flux will be uneven. So it will be, now air gap flux will be what? Non-sinusoidal. Okay, air gap flux will be non-sinusoidal, it will be not pure sinusoidal. So in that case what happens, we will be not getting such type of patterns, that is torque slip characteristics, we will be not getting such things. Okay, instead of this we will be getting some some harmonics present inside this waveform. Okay, here anyhow it is not shown here, will be seen soonly. Okay, fine. So you hope you understood why the harmonics are introduced. Harmonics are introduced because as there is there is a presence of slots in the stator as well as rotor, which makes unevenness in between the between the gap of the stator as well as rotor slots. So that causes what? Introduction of harmonics in the torque slip characteristics or harmonics in the motor, you can say. Okay, and again we know that even harmonics are always absent as their symmetry to each other, so they will cancel out each other. Okay, so we are only going to consider what? Odd harmonics. Okay, we are only going to consider what? Odd harmonics, and that too 5th, 7th, 11th goes on. So totally there are some odd harmonics we are going to consider. You might be wondering where is first and third. Okay, why we are left out with first as well as third, and also why we are left out with the ninth also. We shall see that. We shall see why we are considering only this 5, 7, 11, etc. in coming topic. Okay, so we shall see now first why we are not consider. First of all, I'm going to tell here is, even see the harmonic, like I said, first is missing. No, here first harmonic is missing. First harmonic is your required harmonic. We categorize that also as harmonic. That is your fundamental waveform. Fundamental waveform causes what? It will cause sinusoidal, and the torque slip characteristics will be like this. It will be smooth. That is the first harmonic that actually we need. Okay, the fundamental thing which we need. I can't nullify it. Okay, I can't nullify it. I need to have that in my air gap between stator as well as rotor slots. So that's what happens. That will be always present. Okay, now coming to the third harmonics. So remember, third harmonics here are absent. Okay, anyhow, like I said, like even harmonics are absent. third harmonics are also absent, though it is odd harmonic. The reason why third harmonics are absent, because we know that third harmonics, it follows, it has a phase difference of 120 degree between each other. Just like our AC waveform and all, how the phase difference is 120 degree, the similarly third harmonic also has a phase difference of 120 degree with respect to each other. So what happens if they are 120 degree respect to each other, means those harmonics will neutralize themselves. Okay, they will cancel out each other. So what happens, there is no any odd harmonic of third. Okay, similarly multiple of third harmonics are also absent. That is triple N harmonics. We call it as what? Triple N harmonics, where N is any integer, where 3 is your third order harmonic. Okay, so triple N means 3N harmonics are always absent. Why? Because if I multiply 3 into 1, 3, yes, third harmonics absent. 3 into 2, 6 harmonics, any of it is even, so it is absent. And next 3 into 3, 9, so again it's odd harmonic, so that is also absent. So we have not writing any 9 over here. It goes on like this. So first harmonic, that is even though it is odd, it is not considered as harmonic. That's why I told you that's a fundamental harmonic which I need that. So I'm not categorizing that first harmonic as harmonics in terms of harmonic, which we need actually. So remaining, like I said, triple N harmonics are absent and even harmonics are absent. Okay. So due to this, what happens? Uneven distribution of EMF or unevenness of status slots and rotor slots, that causes tooth or slot harmonics. Okay, and that is what added with unwanted torques as well as vibration and noise. Okay, along with that, we are going to see what vibration as well as noise. Now we will see what exactly crawling is. Okay, so before going to that, we have synchronous speed is given by ns equal to 120 f by p, that is present in the stator part. And again, if I write in terms of rps, just divide by 60, you will get 2f by p in rps. Okay, so crawling is actually is the reduction in the speed of the motor from the rated speed. Okay, remember, crawling is nothing but what? Reduction of the speed of the motor from its rated speed. So motor may rotate lesser than the rated speed as per the nameplate of the motor. Like here taken here example, and one more thing we missed here. Fifth harmonic as well as seventh harmonic are very dominant in nature. Okay, remember, fifth harmonic as well as the 11th harmonic are fifth harmonic as well as seventh harmonic are dominant in nature, whereas the remaining harmonics like 11, 15, 19 like this, or whatever, depending upon your exception of 3N and all what, they are not much dominant. Their effective is very, very less. Their effectiveness is very, very less. So we are not accounting the remaining odd harmonics. Only odd harmonics which we are considering is what? Fifth and seventh. Okay, remember this, because they are very much dominant. Okay, and again, these effects are seen much more in your resultant torque slip characteristics. Okay, we shall see that. So here, like I said, crawling is what? Reduction in the speed from its rated speed. So if fifth harmonics get introduced, okay, if fifth harmonics get introduced in your three-phase induction motor, then what happens? You can see the speed of the motor will get reduced by 1 by 5 times. Okay, if ns is the rps speed, so the speed of the motor will be ns by 5. Similarly, it will be what? 2f by 5p. If I divide this, multiplying 1 by 5 on the both sides. Okay, so speed will be reduced by 1/5 times of the rated speed or synchronous speed. Similarly, we know that seventh harmonic is also getting introduced. Okay, if that gets introduced, then what happens? The speed will get what? Reduced by 1 by 7 times of synchronous speed. Similarly, it will be what? 2f by 7p rps for seventh order harmonic. Okay, remember, only fifth and seventh harmonic are only what? Dominant, and remaining odd harmonics are neglected. It is not like they will be not there, they will be there, but the effect will be very, very less. So we are ignoring them. Only fifth and seventh odd harmonic are only considered. Okay, now we are applying Fourier series. Okay, now we are applying what? Fourier series to know how these harmonics are getting added. Okay, by applying Fourier series and modeling and all, we will come to know that how these harmonics are playing a key role in deciding the torque slip characteristics. Okay, so by applying Fourier series, we have come up to the formula, that is k is equal to 6m plus 1 as well as k is equal to 6 minus 1. Okay, now when to use this formula and when to use this formula. Okay, only plus minus is the difference between these two formulas. So first formula you will be using when the harmonic is in the direction of the fundamental waveform. Say, like I said, no, first harmonic. I told you we have ignored that. That is what actually we need. First harmonic. So what happened? That harmonic as well as this k is equal to 6m plus 1. If the harmonics, that is 5th or 7th, whatever, depending upon the direction and all. If the harmonic is in the direction of the fundamental waveform, then I am going to use k is equal to 6m plus 1. If the harmonic introduced is opposite to the direction of the fundamental waveform, then I will be using what? Minus sign. Plus sign in the direction of the fundamental waveform, minus sign opposite to the direction of the fundamental waveform. And where m is any integer, I can have any value there, and k is order of harmonics. Okay, usually it will be in the odd itself. Okay, k is order of harmonics and m is any integer. It starts from 1 to anything you can add. Now we can see that if m is equal to 1, then what happens? M is equal to 6 plus 1 7 and 6 minus 1 it will be 5. So again, like I said, these 5th and 7th harmonic are dominant in nature. Okay. Next one you can see when m is equal to 2, then what happens? K is equal to 13 and similarly k is equal to 11. Just substitute here, you will getting answer. So again, like I said, the remaining harmonics are not dominant. We are not considering. So I am written here not dominant. And similarly, when m is equal to 3, k is equal to 19 and k is equal to 17. Again, they are not dominant. I am not going to consider. So here you will be not getting any triplet harmonics and all because we have derived formula for by applying the Fourier series and all. Okay. Now you can come we shall see which of these two harmonics, that is 5th as well as 7th, whether it is in the direction of fundamental waveform or whether it is opposite to the direction of fundamental waveform. Very simple. Just see when you substitute m is equal to 1. So what happens here? 6 plus 1 7. So what happens? Plus sign I am going to use. So if plus sign means what? It is in the direction of the fundamental waveform. Okay. So what I can say is 7th harmonic is in the direction of the fundamental waveform. Okay. And again, if you substitute m is equal to 1 in this formula, so I am getting what? 6 minus 1 5. So minus term we are using here. So what happens here? Minus term means it is opposite to the direction of the fundamental waveform. So what I can say here is 5th harmonic rotates in opposite direction to that of fundamental wave. 7th harmonic rotates in the direction of the fundamental waveform, whereas 5th harmonic will rotate in opposite to the direction of the fundamental waveform. Okay. It goes on like this. We shall not restrict to just m is equal to 3. It can proceed further. But like I said, they are not dominant anymore. Only the 1st, 5th as well as 7th harmonic are dominant. So we are considering those. Okay. Now, like I said, crawling means what? Crawling means is the reduction in the speed of the motor from the synchronous speed. Okay. Now let us see torque slip characteristics. This is a typical torque slip characteristic. Okay. Here we'll understand how my 5th harmonic and 7th harmonic are playing key role here. Okay. And again you can see this is actually my torque slip characteristics which I need. This would be the waveform. You can see here the as per the cursor's concerned, how I rotating, right? The same way you have to remember this. See, this is what actually I need. This is what actually I need. This is only possible when the torque slip characteristics are smooth. Again, when there is a air gap flux is purely sinusoidal. But as a matter of fact, what happens for big larger machine and all, torque slip characteristics are not the slots will be there. It will be the waveform will the gap will be uneven. So there will be uniform distribution of EMF. So what happens? The sinusoidal waveform gets affected. So I will be not getting such type of fundamental wave. Okay.